Hello guys, what's going on? Yeah, just welcome back. In the previous video we were talking about it was just a young revision, and right now we're gonna dive into grade 11 things. So to start off, trigonometry for grade 11, we will talk about trigonometric identities. Okay, sure, let's talk about tangent for starters. We know tangent to be we know tangent to be opposite of adjacent, right? So remember, in our smallanyana right angled triangle, let me make it look perfect. So in our smallanyana right angled triangle, you have your theta here, and I'll say A, B, C. We have this thing. Let me just shut up. A, B, C. So then tangent theta in this triangle of ours is opposite over adjacent, which is going to be C over A, right? Opposite over adjacent. That is what we know a tangent to be. Okay, but then to go deeper as well, we went and talk about trigonometric ratios in relation to trig ratios. What did I just say? Damn. Like, we did speak about Cartesian plane and trigonometric ratios. Yeah, let me just say that. So say you have your point here, point P, which is x and y, because both x and y's are positive. Right, and this is your right angled triangle, and this is your theta right here. And so in this triangle, of course, your y-axis, your x-axis, in this triangle, the distance from P to your x-axis, that is y, and the distance from the origin, right, to where the x value of P is, it's just x, right? So now when we do represent these trigonometric ratios using the Cartesian plane, we would say tangent theta is what? Tangent theta is opposite, which is y, because y is opposite theta, right? Y is actually opposite theta over, so it's gonna be opposite over adjacent, which is y over x. We have it right there. But there's something cool that I'm going to show you guys. You also know that we would represent this as the radius, so this is r, saying it's our radius. Okay, yeah, so there's something cool I'm gonna show you guys. Let me, I don't know, should I use the blue pen? Maybe the red one. Okay, let me go with the red one. So you have tangent theta being x, y over x. Say let us multiply by r over r. Ne? So you realize that what we have done here is actually nothing. We have done nothing because r over r is 1. So we haven't even changed what tan theta represent. Okay. Let us separate every term here, every term. So we have y over 1 multiply by 1 over x multiply by r over 1 multiply by what is this 1 over r. Okay, and now I'm going to pair them like this. So I'm going to multiply these two together. All right, I'm going to multiply these two together, and I'm going to multiply these two together. Okay, so after multiplying those, I'm going to end up with something like this. I'll have y over r multiplied by r over x. Okay, and there's something that is so cool when we are multiplying. There's something that is so cool when we are multiplying, and maybe it has a name, I don't know, but like if you have a over b divided by c over d, this is what you have. The next step, we can actually say it's a over b multiply. We change the division into multiplication, and we end up having d over c. So the numerator becomes the denominator becomes the numerator, right? And if I move from here again, I could say I have a over b divided by c over d, right? So you see, like this, yeah, this thing that is happening here is what we're going to use for these products. So I'll just say, I'm gonna write, okay, so the products here they are, right? After multiplying these two, we ended up with r over x. So now let's say y over r. Now we divide and we end up having x over r, né? And this is where I would say let us stop and wonder or think, né? I want to ask you a straight question and be like, what is y over r? Damn, I have so flu. Sorry for that. So what is y over r and what is x over r? I can ask you those questions, but if you have no idea, we'll do a quick recap. We already spoken about tangent, so let's talk about sine theta. Let's talk about cos theta. Right, so sine theta, sine, remember sine, so sine is opposite over adjacent. So sine opposite over, oh no, not opposite over adjacent, that is tangent. Okay, let's go back. Sine theta is opposite over hypotenuse. Okay, because it's, we have opposite over hypotenuse, so that is y over r. And then as for cos, then we go and talk about right? Adjacent over hypotenuse. So adjacent, it's x over r. And when we look at both of these and we look at these as well, we see they are exactly the same thing. So then we're like, okay, cool. Let's say we have sine theta divided by cos theta, right? Which is exactly what? Which is exactly come on, sine theta divided by cos theta. Do you see that? So we have found something so cool now where we could say therefore tan theta is equals to sine theta divided by cos theta. That is so cool. So you guys, at least I'm happy you guys now know where it comes from. But I'll emphasize and say this is the most important part, in a sense that you don't need to know how to derive it, but you need to know that actually tan theta is the same as sine theta over cos theta, right? And on that note, I will just ask you a question. What if cos theta is equal to 0? Like, what if cos theta is equal to 0 right here? What if that is the case? Of course, we're gonna get a math error. It's gonna be what? It's gonna be a math error because we cannot divide anything, right? Even 1 million, you can't divide it by 0. That's a math error. You're gonna get we would say it's undefined or just math error. So exactly, and it even makes sense if you look at the asymptotes of your tangent function. Look at the asymptote, or specifically tan theta. Yeah, you would see that those are asymptotes. They are actually where cos theta is close to 0, right? Wherever cos theta is close to 0, that's where you're going to get your asymptote. And it makes so much sense now, like why tangent function is the only trick ratio with asymptotes. But yeah, and if I'm just saying, just for extras, if you have tan theta plus 30 degrees, right, maybe check where cos theta plus 30 degrees is equal to 0, then you'll find your asymptotes as well. You have quite an easy way to find your asymptotes if you happen to have forgotten how we actually calculate our asymptotes. But yeah, that's under functions. But yeah, that is so cool. Let us continue. There's another one, right? There's another one, so let's cook. We have sine squared theta plus cos squared theta. I will tell you right away the answer is 1, but we're just gonna prove it right now. We're gonna prove it. So sine squared theta plus cos squared theta, that is equals to what? We know sine is y over r, right, squared, plus cos, we know it's x over r squared. And that is y squared plus x squared, both of them over r squared. Right, so you end up having y squared plus x squared over r squared. So now let us come to our triangle and try to apply theorem of Pythagoras. If we apply theorem of Pythagoras here, we have x squared plus y squared. X squared plus y squared is equals to r squared. Remember, this is our radius, right? Yeah, we're cool and we're done. So we now go back and be like, do you see that x squared and y squared added together give you r squared? So we come back to our working and we'll say, therefore here we have r squared over r squared, which is actually which is what, which is 1, right? So we have proven it. And from here, guys, like, you can have cos squared theta is equals to 1 minus sine squared theta, or even sine squared theta is equals to 1 minus cos squared theta, or even many more. You can just continue further to simplify them as far as you want, but yeah. So I would say in most problems you may not even have to do that. But yeah, with more practice we'll actually see. So yeah, we're done with proving our identities. These are just the two identities that I have, and I think on the next page we start solving problems, of which, yeah, we do. So the first question, it says reduce the following to one trigonometric ratio. Let's start. Let's do that. So right here I have okay, let's cook. I have sine theta divided by tan theta, which is sine theta divided by, I know what tan theta is, okay? So tan theta, remember, that is sine theta over cos theta. That means I have sine theta multiplied by cos theta divided by sine theta. And then this sine theta divides this sine theta, and my final answer is cos theta. And I've done it. I've reduced the following into one trigonometric ratio. Cool. Let's go to the, maybe draw a line here. Let's go to the second one. Okay, the second one, there we go. You know, like, the first thing that you look for when you're trying to simplify, you look for what? You look for common factors, right? And these are numbers that appear in all your terms, right? And talking about terms, we have two terms. Remember, terms are divided by pluses and minuses. That's what's gonna tell you how many terms you have, right? But if this was multiplication, then we'll just say this is one term, you know. So let me go back. Yeah, so cool. Let's start. So our common factor here, we have tangent theta both sides, so let's take it out. Tan theta squared cos squared theta plus sine squared theta. That is so cool. Now we did say what this is. It's the last identity we proved. So cos squared theta plus sine squared theta is equals to what? It's equals to 1. So this, and then your final answer is just tan squared theta. Tan squared theta. Then you are done with this problem. Okay, cool. Yeah, so I just want to write something down. Remember, we have cos squared theta plus sine squared theta equals to 1, and I said that we can have things like say 1, we could have sine squared theta equals to 1 minus cos squared theta. We said we could also have something like cos squared theta is equals to 1 minus sine squared theta, and you can continue further. You can like further simplify this one, put square root both sides, whatever. You could also do the same here. it doesn't really matter. And also, I just want to make you guys realize what we have here on both 1 and 2. These are difference of two squares, right? For example, I'm just going to expand number 1, right? For example, you have sin²𝜃 is equals to 1 minus cos²𝜃, and this is, like I said, difference of two squares. So difference of two squares is just going to be 1 minus cos²𝜃, not squared, cos²𝜃, and the other side is going to be 1 plus cos²𝜃, right? You multiply this all out, you're going to get this. Yeah, so the same thing applies here as well. The same thing is applicable here as well. Yeah, let's go back to solving these problems then. Let's go back to solving these problems. So sorry for that. So we have 1 minus cos²𝜃. 1 minus cos² equals to sin²𝜃. So sin² divided by cos² minus tan². You might want to, like here, it's just your way. You might actually maybe convert this to be tangent and say you have tan²𝜃 minus tan², or alternatively, you can just say sin² over cos² minus sin² over cos². So now you change tan² into this, and then your answer is just gonna be 0. So it doesn't matter how you do it. You can change this to be what? To be tan², and you have tan² minus tan². You go down with it, you're getting a 0 after, so it doesn't really matter. But yeah, you get the same answer. Yeah, so I hope this is just easy to understand. But I got you. We're gonna do some exam problems, problems you actually get when you're writing exams. So it's gonna be completely cool. You guys are gonna know how to apply all of these. Cool. We have this one, so we're just proving the identities now. So one thing about when you're proving the identities is like you're trying to prove that the left hand side is equals to the right hand side. That's what you're trying to prove, and when you're doing that, you'll pick a side, right? You look at the problem, you wonder to yourself which side will be easier to simplify or whatever, and then the side that you think is the easiest, because sometimes different people will find different sides easier than the other. So you will just pick, okay, I find this side easier to manipulate, whatever, and you pick that side and you work with that side. But sometimes both sides work, sometimes you can only use just one side. I'll just show you. Cool. Let's go start with A. It doesn't, like I said, it doesn't really matter which side you pick. No, it does matter for some problems, like like C here, but we'll talk about it. For number A, it doesn't really matter. So I'll do both sides just to show you guys. I'll do both sides. So say left hand side is equals to 1 plus sin theta cos theta. Say I multiplied by, because I'm seeing here I could get difference of two squares. I multiply by 1 minus sin²𝜃, right? 1 minus sin²𝜃, right? No, not ²𝜃, man, not ²𝜃, just 1 minus sin theta. Yes, exactly. So after multiplying these, my numerators, I know that's difference of two squares, so it's just gonna be simply 1 minus sin 1 minus sin²𝜃, because it's just purely difference of two squares. And then I have cos theta into 1 minus sin sin theta. This gives me what? It gives me cos²𝜃, cos, okay, into 1 minus sine theta, right? Cool. Then the next thing I do, I'll say I have, what do I actually have? I have cos. Okay, let me just say I have cos²𝜃, multiply by cos²𝜃, which is just cos²𝜃, and then I have cos² into 1 minus sine theta, and then one of my courses divides with one of my courses, and I just have cos theta divided by 1 minus sine theta, which is exactly what we have this side. So then in this case, I'll then say therefore left hand side equals to right hand side. Now I'll show you this side. See, I decided to work with the right hand side, so right hand side is equals to cos theta, 1 minus sine theta. So here I multiply by, I see difference of two squares. So cos, no, 1 plus sine theta, 1 plus sine theta. So I have cos theta 1 plus sine theta, and I have 1 minus sin²𝜃. Eventually I have, okay, I have cos theta 1 plus sine theta, and then this is cos²𝜃, guys, cos²𝜃. So I'll just write it as cos theta multiplied by cos theta. This cos theta multiplied by cos theta is coming from this cos²𝜃, which is coming from 1 minus sin²𝜃. So in this case, then my courses, they divide, and eventually I just have what? Eventually I just have 1 plus sine theta divided by cos theta, which is exactly what I have on my left hand side. So then you will just say right hand side equals to left hand side. Therefore, this is just how we do the proofs. Now this is how you do the proof. You'll pick a side and then you'll try to manipulate that side, try to make it into what the other side looks like. So I'm gonna remove this one and we will start working on B. Just remember, if you can pause the videos and go back, if you didn't hear what I said. Yeah. Cool. So we have this one here. So for number B, it's one of those where, like, you really, like, there's actually one side that works. Like the other side, it becomes a bit of an issue. It becomes an issue if you try. This side specifically, it becomes an issue. I will say give it a try. Give it a try and see, like, what happens. Because, like, some numbers, like, it becomes a question of, like, how are you gonna get this number? Like, you can't just, but yeah. Like I said, also, like, different people find different sides, easy. So someone will find the side easy, and that's okay if they can turn this side into this side. But if you can't, then you move to this side and turn it into this side. So let's do that. You have right hand side. You see here, we have common factors, but just the basic law: when you multiply, when you adding or subtracting fractions, the denominators has to be the same, right? So you'll say you have sine squared, sine theta, plus cos theta, right? Let me just sine theta plus cos theta. We will multiply it by sine theta plus cos theta. Yo. All right, this is what we're doing. Then you have 1 all over sine theta. I want to say cos theta, right? So then you have sine, oh no, sine theta plus cos theta squared, and yeah, sine theta plus cos theta minus 1. Right. So if now let me try to expand this now. So if I expand it, then I'll have sine squared theta plus 2 sine theta cos theta, plus then I'll have cos squared theta. Then I have minus 1. This minus 1 is coming from here. And then I have everything over sin theta plus cos theta. Okay, cool. So I'm gonna do this guy and this guy added together, they give us what? They give us 1. So that means we're gonna have 2 sine theta cos theta plus 1 minus 1 is equals to no over sine theta plus cos theta, right? Yeah, so this is we're still cooking. I hope you guys are following. We have sine squared theta plus cos squared theta added together, they give us this 1, then minus this 1. So after doing the subtractions, right, this is gonna disappear because that's gonna be 0, and you end up having this guy as your final solution. This ends up being your final solution, which is exactly what we have right here. You see, so then you would say, therefore, right hand side is equals to left hand side. We did prove these. Né? Let me come back. You see here, they did say we must state restrictions where it's appropriate. Né? Like on these sides, it depends which side you're proving. Yeah, it depends which side you're proving, because you already see here cos cannot be 0, but then here on this one, what matters is 1 minus sine theta. It cannot be 0. You understand? Yeah. And then when we come on this side for B, sine theta plus cos theta, they cannot be 0. Whatever they will be, it's fine, but they cannot be 0. So those will be your restrictions. Let's do number C. Number C is a good example of you. There are times where you will have just one side you can only possibly use. Like, I mean, how are you gonna move from this to this? Yes, of course you can. I don't want to limit you guys. Now you can think outside of the box, right? You can think outside of the box and try to bring things into the equation. I believe in you guys. I believe in you. Yeah, but remember, in this channel we're gonna take it easy. We're trying to make math easy, which it is. So cool. So let's do number C now. I will do, of course, the left hand side. So left hand side, I have 1 over cos so 1 over cos theta minus cos theta times squared theta all over 1, and already I just want to multiply by cos theta over cos theta, because remember it's fractions and we're subtracting, so same denominators. Then I have 1 over cos theta, then I have minus cos²𝜃, and allow me to change my tangent into sin²𝜃 divided by cos²𝜃, right? And then I have no, just cos²𝜃. Right, so then I have 1 minus, what's going to happen is my tangent is going to exactly divides with that 1. Then I have 1 minus sin²𝜃 divided by what? Divided by cos²𝜃. Then you remember that, no. 1 minus sin²𝜃 is what? Is cos²𝜃. Right. So we have cos²𝜃 over cos². Divide the 2, you're just going to get cos². Done and dusted. Then you will just say, therefore, left hand side equals right hand side, and you are done with your example. Understood? Yeah, that was cool. Let's do the last one, and we will be done for this video. So on the last one, we have I'll pick the right hand side. I still feel like also the left hand. No. I'll pick the left hand side. I'm sorry. So I'm gonna use this side. I feel like this side is one of those as well. Like, you're gonna have to think really hard in order for you to take this and change it into this. You're gonna have to think really, really hard. But yeah, you don't have the time. The exam is almost done, and you just found this question 5 marks or something, maybe 4, and you need those 4 marks to get your 90%, to get your 100%. Of course, you're gonna pick the left hand side. So let's do it. So left hand side is equals to, we have 1 plus tan squared cos², 1 minus tan theta. All right, cool. So here's what I want to do now. Yeah, because I'm seeing I'm running out of space. So here's what I'm gonna do. I'm gonna work them parts by parts. So as for these are my numerators. This is just for my numerators. Let me start with my denominators. So I have cos² divided by cos², which is 1 minus sin² over cos², which is cos² minus sin² divided by cos. Okay, cool. So this is my denominators. So now I'm gonna write the left hand side like this. I'm gonna write it like this to say left hand side is equals to, so I have cos² divided by cos² plus sin² all over cos², right? Yeah, in fact, let me just say numerators first, not tas, numerator. So as for my numerators, then I have cos². Let me change the colors now. It seems, yeah, cos² divided by cos², that is for 1, sin², that is for tangent, right? Multiply by cos². Then I'll say is equals to, I'm gonna have sin² plus cos², divided by cos²𝜃. The whole thing multiplied by cos theta. Yeah, that is cos theta, guys. That is cos theta. So yeah, don't have space. So that means that I have 1 divided by cos theta, because this cos theta divided by, when we divide by this cos theta, I end up having 1, 1 minus cos theta, and then my numerators here, that is basically 1. There's a squared that I left here for cos. Yeah, so then I'll say left hand side. Let me go with the red color. Left hand side is equals to, of course, my numerators, which is 1 over cos theta, 1 over, and then divide by my denominators, which is what? My denominators, it's cos theta minus sin theta divided by cos theta. That is just 1 over, it's just 1 over when I said damn, this is then multiply by cos theta divided by cos theta minus sin theta. And then what's going to happen, they're going to divide each other. Then your final answer is going to be 1 all over cos theta minus sin theta. Booyah! So you are done. You have your left hand side, which is here, it is matching your right hand side. Therefore, you have proven that the left hand side equals to the right hand side, and yes, you have proven the identity. You have your 100%. You're done. Thank you so much, guys. See you for the next video.